Okay. What's this?
For the slides I just joined.
Oh, for the watch.
And then me.
I have an 80.
That was what I was thinking. What's your middle name?
Starts with a B. You want to guess?
Big Bunny.
Remember, Jewish family. Middle name is Barry. 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 I have a really interesting family heritage.
No. I mean, we just started yesterday.
So part of my, should be good. So my whole family is like Orthodox Jew, and then there's a portion of my family that isn't. They're not alive anymore, but they were in the Russian mafia. And then, but we're originally from Jews from Poland, so a lot of my family got pulled into Auschwitz during the war. And that didn't work out so hot for them, but yeah, it's the way it goes. That's how I mean, this is history, right?
I think a lot of my family came from Italy. I'm like 116.
Now I'm LCMS, which is like 98% German. It's like ironic. Well, based on the question you asked earlier, how many countries I've been to? I've been all over the world to many, many, many countries, and I'll tell you what, most humans are pretty good people, and the jerks are the same everywhere. So, it doesn't really matter what country you came from. From an American perspective, our whole life we've like demonized Russia. I don't know, when I was in Moscow, the Russians were pretty cool. You know, they were fine. I mean, they're like us.
You should go to Vietnam.
I'm going to.
When I was in my country, every people thinks that like Americans are like angels over there, like they're really nice, really cool. Nobody's doing anything bad. That's what we think.
Well, that's
That's
just ignorance of the world.
But
You
then
got
I
some
changed
crappy
my
people,
mind.
and you got mostly good people. Everywhere you go.
That's true. So it's like a new world.
Well, I have been reading up though for the trip to Cabo. Apparently, I have to. You want to get all prices in pesos instead of in U.S. dollars, because if you pay in U.S. dollars, they give you a worse conversion rate to pesos. They like charge like 15% more for everything.
Okay.
Where if I just pay for it for pesos on my credit card will do the conversion.
Mm-hmm.
Yeah. Plus, then you got to also worry about them like just stealing you. At a gas station or something like that, which would be fun. Wouldn't that be like a great vacation story?
Free transport.
I already rented a car, so now I'm going to have to pay late fees when it doesn't come back on time. But that would just be a great story.
To get kidnapped.
Yeah. I mean, you don't want to die, but just to have that.
Why would they like
I mean, my wife and I have a story one time we were in St. Martin, and this was when we were a lot younger, and she was less wise. And she assumed that I knew what I was talking about. So I didn't want to go from the British to the Dutch side of, French to Dutch, yeah, whatever, side of St. Martin. You have to take a cab, and they overcharge for the cabs tons, like $50 for like a 8-minute ride. So I figured, we were off the beaten path, and we saw this guy in a black van with a cardboard sign. It says taxi $2. Seems legit enough, right?
Oh, yeah.
So we hire the black van guy. Speaks no English. He's up there screaming in French or something, and we're driving, and after about a minute or two, he picks up, I don't a woman of the night, let's say. They're fighting in the front, and then we pick up like this vagrant, and then there's gunshots, and our windshield gets blown out. So this guy's screaming and stuff, and he's like wiping away the glass and like going really fast up on the curb and stuff. My wife's like flipping out. I'm like, $2. So we get over to the other side. He's not even allowed to go into town. He has to drop us off like in the outskirts. Yeah, our windshield got shot out.
Oh my god.
Yeah, so the taxi ride to the other side and back cost me $42. $2 on the way there, full fare the way back. I mean, what are the chances of that happening twice is what I was trying to explain to my wife. And
I have a fact that he wasn't allowed in town. Should have been kind of a warning sign. Like, maybe we should ride with him for $2.
She thinks the same thing with like air travel. She had never flown before she had met me. And I was just saying before class, like, and it's funny, when I was a kid, I was afraid to fly. But now I'm like all into like extreme turbulence. Like when the when like the flight attendants are like screaming and stuff. Yeah, seriously. I mean, we've been on planes where like the oxygen masks come down, and I'm like, oh, this is go time. Like all excited. My wife is like flipping out. But she used to look to me, and she figured, oh, if he's calm, it's fine. You have to look at like the pilots and stuff. As long as they're calm, it's fine. Oh, the stories are endless. Okay, so we're talking about databases. So now in here, I'm not going to go into very much detail about the inner workings of database. That's something that's left for the CSC300 class, the database class. It'll tell you how to organize the database, how they actually work under the hood and stuff like that. We're thinking about it from the practical perspective. What do we use databases for? Okay, so we talked the last time that a database is a place that stores data long term. Now, a database does not dictate where it lives. You can have a database that's local on your computer. You can have a database that's local on your phone. Or, what's probably more common for most of the applications we write today, we have a database that lives in the cloud somewhere, where our devices over the internet communicate with the database for storing information. Does that make sense? Okay, but understand that database does not necessarily dictate that where it lives. All right? It is a container for storing data in such a way that it is likely searchable and queryable. So this is, let's say, better or more powerful from a programming perspective than storing stuff like in a file on your hard drive or something like that. So think of a database as kind of like that on steroids. In fact, the early databases were flat file databases, or you would just write your own proprietary thing where you store all your stuff as like a comma separated values, a CSV file inside of a text document or something like that. Well, now most of our modern applications, if you need to store something offline, for example, you want the stuff to still be there when your app launches again, they have mechanisms to do that. Now, there might be some applications that really don't need a cloud-based database because you do have to consider that over time can cost some money. Most of the options are free for, kind of personal use and up to a certain number of transactions per month, that kind of thing, and then you have to start paying for them to encourage developers to use the tool. And for instance, any assignment we do in here is not going to, where you don't have 50,000 users using it and things like that, so you're not going to come anywhere close to when you would have to start paying. So everything's going to be free for us. But punchline is that the big databases, they want you to utilize them as a student or as an independent developer so that when you do push something out commercially or that's going to have a lot of users, then they start getting money from you. Okay? So we talked last time about some popular databases like Oracle, Microsoft SQL Server. So let's call these two guys kind of enterprise databases. Oracle is probably the most famous enterprise database. Microsoft SQL Server, we'd also call an enterprise database that is very likely to be used in a situation where all their servers are Microsoft stuff. All right, so a lot of times Microsoft gets demonized for their stuff, but their stuff is good, but it works best when all your stuff is Microsoft. No different than Apple's stuff. Apple's stuff works best when your entire ecosystem is Apple. Make sense? All right, so nothing wrong with Microsoft SQL Server, just you would only probably pick it if all the rest of your technologies were Microsoft. When we start getting into kind of independent developer tools, MySQL is a pretty popular free database. Another one is called PostgreSQL, another free database. And then we have one called SQLite. SQLite is also free, and it's always, there's probably some example where somebody hosted it remotely, but let's just say practically it's always hosted locally on the device. So SQLite is kind of designed to be a single user local database that gives you a queryable connection to your data without a whole lot of setup. You know, it's not a major thing. It's kind of whatever the bare minimum is of storing something offline in a queryable way. Not made for having more than probably 2 or 3 users hitting it at the same time. Whereas something like Oracle is designed for like places like Amazon, you know, where you have millions of people doing searches for products and things like that, potentially all within several seconds of each other. All right, so it's a lot of times the cost of these guys has to do with their ability to handle lots and lots of transactions. All right. Now, these guys are all what I call relational databases, and you'll learn about that in 430. Kind of a newer style of database that isn't necessarily better, but and you're going to see an example today on why I find it very good for mobile applications. Is this idea of a real-time database, also known as NoSQL databases, even though they almost always have a fake SQL kind of language for querying them. Kind of the 50-second or the 5-second tour of this is relational databases came out during a time where we really needed to be careful about how much space our data took. You know, memory was expensive, we didn't have tons of it, things like that. So its whole focus is on minimizing your data footprint, not duplicating data. Where real-time databases, NoSQL databases, go in the other end of the extreme. We care about performance. Duplicate the data 500 times, who cares? We have unlimited data. Very different thought processes. Understand that there's nothing wrong with relational databases. This isn't an upgrade thing. It's right tool for the job. All right, and a popular free one that you'll see a lot of web technologies gravitate towards these days is something called MongoDB. You know, probably your two most popular web-based, independent programmer databases are MySQL and MongoDB. Those are probably the two. The problem with any of these, like MySQL, PostgreSQL, even Microsoft SQL Server or Oracle, I mean, these top two, it's dollars, how much it costs to get them. But the problem with any of those is that you need to find a place to host it. All right. Now you can work on your application and have your MySQL living on your local computer and have your app living on your local computer. So when your app writes to the cloud, it's actually just writing to your hard drive. It's writing right onto your computer. Now that's fine for testing and fine for learning, and it doesn't matter whether your database was local or your database was somewhere up there from a programming perspective. But from a practicality perspective, you're probably not going to release an app on the App Store that's going to require that your laptop be open with the server running and connected to the internet in a way that can be reached by everybody who downloads your app, where your app acts as a database server. Not the most practical use of it, right? So then you have had some tools that kind of came out. So for instance, How many of you have heard of something called Heroku? Okay, so Heroku is let's call it a hosted Unix environment, but I would call it what's called a platform as a service. So you don't really get to remote into it and use it as a Unix or Linux system. They kind of have the Heroku way of doing things. They give you a command line thing and stuff like that. But it allows you to host a MySQL database or a PostgreSQL database or a MongoDB. I think it supports MongoDB, but that kind of stuff. So somewhere that's not on your computer. Similar to what I said before, Heroku is free until you have enough users where it shouldn't be free anymore. That type of thing. So if you're just doing it for your own stuff, it's probably fine. I have found that Heroku is great for web applications. That's really where it shines. We're not writing web applications in here. We're writing mobile apps. Okay? So the tool we're going to look at in here is something called Firebase. So Firebase is now owned by Google. When I first started using Firebase, it was not. Google acquired the company, and they've put all their eggs in that basket now. I think I mentioned last time, all of Android's push notifications actually go through Firebase now. So this guy's here to stay, which is one of the reasons why I like it so much. Prior to Firebase, I used a tool called parse.com, which was really solid, but then they went out of business. They released their server so you can open source and run the server yourself. And you can run it on like Heroku if you wanted to. But now you're in charge of data backups and all this stuff. From a programmer's perspective, and this kind of gets into the world of where are your expertise. All right. Now, some of us are kind of jack of all trades, right? You know about database stuff. You know about programming stuff. You know about server maintenance stuff. Okay. But most of us will probably have at least, once we get into industry, some specialty. The thing that we're best at, right? So if you're best at database stuff, you'll go and be a database administrator, a DBA somewhere. Get paid big bucks, and your job will be to maintain the database. And you'll write some scripts and things like that for doing database calls. Usually it'll be like stored procedures that programmers will ultimately use, but they'll call your stored procedure to get specialized data out of it in the most optimal way, something like that. But that would be your job. If you're a programmer, you might use a database, but your expertise in that database is likely going to be limited. Okay? So one of the things that we want to focus on, it's great from an education perspective to kind of become a jack of all trades, so we kind of dabble and kind of know what do we like, what do we hate, things like that. But when you actually get into industry and you're doing stuff professionally, you're probably going to become very, very, very good at one thing, and then everything else will be something that maybe you have various levels of competency in, but you're probably going to rely on another expert for those things. All right, so Firebase, owned by Google, so has some staying power from that perspective. It is a real-time database. All right, and that's the most important thing. I'm going to show you that today. This idea of it being a real-time database just plays right into mobile application development. It's awesome for mobile application development, especially Android application development, since it's owned by Google. So there's a little drop-down inside of Android Studio that says integrate Firebase. Okay, so it's pretty easy to connect as long as Firebase is behaving. It is no SQL. Data is actually stored. Data in JSON format. Okay, and last semester we talked about JSON and XML. Okay, so it stores it in JSON. Not that important, other than the fact that that's just the format it's in. Go ahead.
Are we ever going to learn how to configure JSON and XML or something similar?
I don't know what you mean by configure. We will use JSON.
Okay.
Yeah, but configure doesn't really make sense.
No?
Like Java, like we did with
Well, you did C#, yeah. So, I mean, JSON is a data representation language. So it stores information about an object in name-value pairs. So we're going to see that in here.
Yeah, because
So you're actually going to see what you're asking.
Yeah, because whenever I go into the files, I usually don't understand too much.
Yeah, you're going to see what you're asking, but the magic kind of happens behind the scenes.
Okay.
But we'll talk about it. But in some course, we will actually write our own parser, but we won't in here. But you'll see the two sides. I have a real object. I have JSON. It's stored up there in JSON. When I bring it back down, it's an object. When I put it up, I go from object to JSON. All right, but Firebase does the magic. Okay, so that's what Firebase is. It's not the only kid in town. I'm going to throw a couple things in here. So we have Micosoft Azure. So this is Microsoft's cloud computing platform, where we can say Firebase is Google's cloud computing platform. Does that make sense? And really, when we say cloud computing, we're saying somebody else's resources in the sky. We can leverage somebody else's resources that live somewhere else so that we don't have to maintain our own server. We don't have to have the highest end hardware, all that stuff. Okay? So, and this is a really important concept because and this is real fresh data here from the perspective, we've had some recent students who've come out and had issues with interviews because they'll get asked questions about cloud computing and they don't contextually know what it is, even though they've seen Firebase before. They're not connecting those dots. Go ahead.
Is it kind of like, because like OneDrive is where you share like documents on a cloud, is that like to a more, like a different extent? Is that like? Well,
OneDrive would be, very likely OneDrive is housed inside of Microsoft Azure.
Okay.
That's how they implement it. But OneDrive would be kind of real-time data storage, one of the capabilities of cloud computing.
Okay.
So cloud computing usually has kind of real-time quick data storage, then it has long-term large data storage that isn't as fast but can hold larger amounts of data for less money. Then you have kind of the database aspect of it. A lot of them have compute power where you can, if you're doing some sort of simulation thing, instead of you using your laptop, maybe you use their supercomputer to pull off. And now a lot of them are putting like machine learning tools and stuff into it for that kind of stuff. So it's when we say cloud computing, let me just create a slide for this. When we talk about a cloud computing platform, what we're really talking about here is a suite of services offered by a company that allows you to leverage their hardware/software outside of your computer. All right, and this is going to come in the form of data storage, usually multiple versions of data storage. Computing power, that is using their CPUs for numeric, lots of complexity type of things. Could be machine learning stuff has become pretty popular, so on and so forth. These guys come in two flavors. They come in IaaS and they come in PaaS. IaaS is infrastructure as a service. PaaS is platform as a service. What does this ultimately mean? Infrastructure as a service says they give you an OS that is backed by their magic, and you get to do whatever you want. Platform as a service is they give you an API that forces you to interface with their hardware in a specific way. All right, pros and cons to both of them. Punchline would be IaaS lets you do very custom stuff at the cost of difficulty. If you're going to write your own custom, if you have IaaS, you might install your own database in there that's backed by their compute power, or you might use their elastic computing platform or that kind of stuff. Where a platform as a service says, look, we already have all the tools you're going to need for cloud computing platform, or cloud computing stuff. If you want to write something to the database, you do it this way. If you want to ask for some computation power, you do it this way. That kind of stuff. Much, much easier to work with at the cost of, you don't have the customizability. Make sense? So both of these are good. Microsoft Azure, this guy is a platform as a service. Firebase is a platform as a service. And if we throw one more guy out here, Amazon Web Services. This is an infrastructure as a service. Okay, and Amazon Web Services, AWS, is one of the most popular cloud computing platforms, but it's most popular in customizable situations where you need to do something a very specific way, maybe related to your business, and you want to use Amazon's computing power behind the scenes as if you own it, at the cost of you having to write your own stuff to do all your magic. As opposed to Firebase has stuff that just says, hey, you want to store something in Firebase? Do it this way. You want to read something from Firebase? Do it this way. You want to send push notifications with Firebase? Do it this way. That's just how it works. Make sense? All right. So do we understand the concept of cloud computing? And that there's multiple vendors that offer cloud computing solutions. We're looking at Firebase, which is Google's version of Microsoft Azure. Okay. So if you're ever asked in an interview, to what your experience is with Microsoft Azure, your answer would be something, assuming you haven't had experience with it, your answer would be something along the lines of, well, I haven't worked with that cloud computing platform, but I have worked with Firebase, which is Google's equivalent. Now they expect that you have a concept of what that's all about. You just haven't worked on the Microsoft version of that. Make sense? As opposed to, what is that? And then getting hung up on by a recruiter. True story.
Wait, so like that example you gave before, the other cloud computing thing was that shut down. Was that an IaaS one?
Which one?
The one you said you used to use, it was like.
Oh, Parse was PAS. Yeah, almost always if I'm writing an application, I'm going to use PAAS. It is simpler. I wouldn't just say it's simpler. It definitely is simpler, but you're stuck doing it their way. But this kind of goes back to the concept I mentioned a few minutes ago, as if your strength as a programmer, you don't need to manage a database and manage all these other things. There's people out there that's what they do. Okay, so we're leveraging that. But as a computer scientist, we always also want to solve problems using the best tool for the job. So if you're doing something very customized, for instance, Netflix used Amazon Web Services for hosting Netflix because they have a very, very unique compression algorithm. So they couldn't just use Firebase's built-in data storage and streaming services because that's going to be their generic stream a video, where Netflix is doing something that's not generic. They're doing something very specialized. So they were forced into that tool, even though it wasn't easier to use, it was the only tool that would allow them to accomplish what they needed to accomplish, other than building their own server farm, which they didn't have the money for initially. Make sense? So it's not that one is better or worse than the other. It's ultimately the right tool for the job, but it's probably fair to say that 9 times out of 10, a programmer is going to benefit from a platform as a service over an infrastructure as a service if they are doing, let's call it, generic database stuff or data storage stuff, storing, taking pictures, storing an image somewhere, that kind of stuff. Use something that makes it very easy. Okay? But for our perspective in here, understand what cloud computing is. Heroku would be another example of a platform as a service. So understand the idea of cloud computing, that is, we get to use somebody else's hardware. Okay? and their expertise and all that stuff because their stuff is better than our stuff. And as students or as lightweight developers, we probably don't even have to pay for it because it's in their best interest to have a whole bunch of freebies who become experts in their system so that when you go get hired by a company and they say, okay, well, we need to pick a cloud computing platform and you're already familiar with Firebase, you could say, oh, well, we should use Firebase because of this, 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 and this. Also because I also know it. And the perception would be that their platform is likely going to be big enough where the thing you're building is going to be big enough that Firebase, Google will make money off of it. Make some sense? Okay. So in here, we will be using Firebase for convenience. Works really well with Android, and Google owns it. It's not going to go away halfway through the semester. Okay? So from our perspective here, this is our app that lives on our actual device. Now we want to talk to something that lives in the cloud to store some stuff. Okay? Now, let's go over to the Firebase side of things first. So I'm going to I'll go to firebase.google.com. That's going to bring you to a place like this. If you don't already have an account, create an account. You'll use your Gmail account to log in. Once you're in, it'll probably ask you to create a new app, but wherever you see Go to Console, click on that. That's going to take you to a place that looks like this. All right, and I already have a couple of things on here, and the one we're going to be using in our example app here is this one here that I already created, but I'm going to go through the process of creating a brand new one and showing you how to hook an Android application up to it so you understand that connection. Because if you just try to go off my code, it's not going to work because your Android application needs to know how to talk to Firebase. Okay? So I'm going to go ahead and I'm going to create a new database here. Now you can actually do this from the Firebase side of things if you wanted to. Okay? In fact, I'll attempt to show you both ways. Okay? Last time I did this, I had some issues with Firebase, but hopefully it's working now. So we're going to add a project. We're going to say CSC300 from Firebase. We'll set it up from Firebase and then use it on Android, and then the other one we'll do to Firebase or something, just so you see both sides. We're accomplishing the same thing. All right, so name it whatever you want. I'm going to say accept this. I'm going to create this project. This has nothing to do with Android yet. Okay? So this is 100% about working with Firebase and having your database in the cloud that you can then go and connect an iPhone app to, an Android app to, use it just directly, all sorts of web applications, Python, blah, 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 blah. Okay, so my project is ready. So it's going to take me here. All right, so now you see over here, there's all sorts of things that this cloud computing platform provides for me. Authentication, database, storage, web hosting. I can have stored functions. Here's machine learning. Pretty compatible with what I've been saying about cloud computing. What we care about in here right now is just database. All right, so I'm going to click on database. Because at this point we have a project, but we don't actually have a database created yet. So I'm going to come in here. I'm going to say create database. All right, so this is where things went weird the other day. We'll see if it's the same. So by default, so you have two different versions. You have locked mode, which is the default, or test mode. Locked mode means your database can only be modified by an authenticated user. Well, we're not going to do authentication in here yet. So we want to put this in test mode so that our database is publicly readable and publicly writable. Definitely not what you want to have for production, but this will be the path of least resistance for getting our Android app to talk to this guy. We're basically making an unsecured database in the cloud that anybody who has the correct database ID can talk to. Okay, so we're going to say start in test mode. I'll go ahead, hit enable. All right, and my database is ready to go. Now notice up here it says database, and then it has Cloud Firestore. And if I hit the down arrow there, we have this thing called a real-time database. I'm going to switch to real-time database. Reality is this Cloud Firestore until recently was in beta and just got released, and I haven't used it. For all intents and purposes, it may actually be better, but I've used this other one. Let's just roll with it. Okay? So we're using their time-tested, real-time database, whatever. And so you have this thing that looks like this. Okay? So now what I'm going to do, so that's on the Firebase side. So now I'm going to go create a brand new Android application. I'm going to end up deleting. We're not going to do our code in there, but just to show you how the hookup works. So I'm going to go over to Android. I'm going to say File, New, and I'll just call it My Application because I'm going to end up dumping this anyways. Just going to go ahead and create the quick app. I'm not even going to do anything with the interface or anything. All right, so here is our basic blank Hello World starting Android application. Let me let Gradle finish building here just so we don't have any weird issues. Okay, so when you're ready to have your Android application connect to Firebase, and this doesn't have to be a fresh application, you'll all be able to do it with your current application. You go to Tools. You have this thing in here called Firebase. Click on that. It's going to bring up the Firebase Assistant over here. All right, and we want real-time database. Okay, in fact, actually, it looks like this guy doesn't even have that Firestore database enabled in it yet. So I don't really know much about it at this point, so we'll just pretend like it doesn't exist. So I'm going to choose real-time database here. Then I'm going to say save and retrieve data. All right, so here's the steps that we need to accomplish. The first thing is we need to connect to Firebase. Now, the first time you do this, it's probably going to ask you for your Firebase username and password. Mine's already in here, so I'll say connect to Firebase. It's going to start the connection thing. Now, I mentioned earlier you could actually create a new project, right? So you can create a new Firebase project here, and it'll create it for you on Firebase, which is what we already did. But I'm going to go ahead and I'm going to choose an existing Firebase project. And here's the project we made here from Firebase. So I'm going to say connect to Firebase with that guy. And it's trying to connect. And presuming it works, we should get a little green check mark. There's our green connected, check mark connected. So our app is now talking to Firebase. Next, we need to add real-time database to our app. So I'm going to click on this. And this is going to make some changes. Can I not zoom on this? I'm trying to zoom, but I can't, so you just have to squint and read. All right, so it's going to make some changes to our Gradle files. And actually, one of these changes is broken. This one here, and I'll show you how to fix it. It's like a weird bug in the current Android thing. But it's going to add to our top level build Gradle, so our entire project. It's going to tell it where to get the information related to Firebase, which is Google services. So when your app first launches, when Gradle first goes, it's going to download Google services, this version, to your Android application, so you have access to those libraries for talking to Firebase. All right, it's going to do it for you. This next thing says, for my application, not only do I need the Google services in here, I also specifically need the database stuff. All right, So it's adding the necessary lines to your Gradle files, which is your auto build files for Android. It's adding those lines. So I'm going to say accept changes. Okay, so you see that it says Gradle project failed, sync failed. It's because of that bug I told you about. Let me go and look at the line real quick. This is in your app. Build.gradle. Yeah, it's just 1601. All right, so over here on the left, where it says Gradle scripts, now you could actually just say open build view or something like that, but the problem is here inside of under the Gradle scripts, there's two different build.gradles. One is at the project level, the other one is at the app level. The problem we have here is the app level one. So click on that. And the issue is here with this line that they put down here. So my guess is when they were updating Android Studio to do this, they were going from 15.0.0 to 16.0.1. And instead of deleting the 15.0.0, they tacked it onto the end.
I don't have that line at all.
You don't have any of these lines?
No, just that one.
Well, then you haven't done this add real-time database button yet.
Oh.
So that's where that line got created. All right. So what I'm going to do is I'm going to come in here. I'm just going to remove that colon 1500. Leave the rest alone. Okay. Then I'll go ahead and click try again. That's because you don't have that line. All right, so Gradle build finished, we're good. But notice here that this guy right here is not happy. Well, it's not that he's unhappy. He just doesn't think that we've actually enabled the database. We have. Okay, we have, because it's looking for the entire string that we had in here, which was not a good string. Okay, so you'll click this button, let it do its thing, go in there, massage off that, take a little buzzsaw and cut that last little piece off, and now we're pointing to the correct place for Firebase. That make sense? At this point, our project now knows how to talk to that specific database in the cloud. Go ahead.
Is that red underline? Anything?
No, that's just because the app compat is they're moving away from it soon. It's fine. All right, so that makes sense from this side. Similarly, if I go ahead and close this app and I create a brand new app, so I'll create a new project, call this guy My Application 2, and I'll choose Empty Activity. Go ahead and let it finish. I'm going to do the exact same thing, except instead of having it connect to an existing Firebase application or Firebase project, I'll have this guy created for me. Okay? So I'll let Gradle finish building here. I'll go to Tools, Firebase, same thing we did before. I'll go to Real-Time Database, Save and Retrieve Data. First thing I'll do is I'll connect to Firebase, and this time it shouldn't ask you for your username and password because it's remembering that stuff. And I'm going to tell it to go ahead and create a new Firebase project called My Application 2. We'll just go with that. Okay? So I'll say connect to Firebase. It's connecting our app to Firebase. And hopefully it works from this side too. Okay, now it says connected. I'm going to show you something. Actually, let's go ahead and connect the database while we're here. So I'll hit this button, add real-time database. Same exact thing we had before. So go ahead and accept the changes. Let it do its thing. Gradle will break. Go in and fix the line. Then you're done. All right, so I'll go ahead. Now you can click down here if you want to get to the file, or you can go into Gradle scripts and open it. But this is our app level Gradle script. So I'll come down here, just remove that portion, and then click try again. It'll be happy this time. Now notice this, I don't know if you saw it over here, but this was green for a second when it thought it added the correct line. But as soon as I changed the line it had added, it now thinks we haven't actually done it. We have. Your final state of this part right here, step 2, should be a button that says add it. That's correct for us right now because of the bug in Android Studio. All right, Gradle worked just fine. So this was the fix for that. If I go back over here to Firebase now, I'm going to click on Firebase up here. I'll go ahead and hit refresh. And here is my application too that it created for me. If I click on this guy. All right, so this is actually good that it pops up. So when I first clicked on that, you see how it says you need to choose data sharing settings for this project? So I'll click on choose data setting sharings, blah, blah, blah. Oh, yeah, that's not what I was thinking it was asking us. You could just do whatever you want. Select it, say I'll share it with Google. Okay, but what we need to do is we need to go over here to the left and click on database. All right, now do I already have a database in here? Looks like it does not actually create the database for you. It just creates the project. So we have to say create database. We're going to say start in test mode. So you still have to do this stuff on that side. Otherwise, you won't have the database. Click enable. And there we go. And then I'm going to switch from Cloud Firestore to real-time database. All right, now the one thing I'm going to double check here, because I had this issue last week, but I said that Firebase was kind of on the fritz when I was doing it. It seems to be working fine now. I'm going to click on rules here. Yeah, it did. Even though I said set this guy to be public, it didn't actually make it public. These are both set to false here. So I'm going to come in here and I'm going to change them both to true. That basically says my database is completely read and writable. Okay? And then I'm going to click publish. And it's probably going to give me a warning. Give me a warning? Nope. Seems to be happy with that. Must think I know what I'm doing. And at some point in time, I think they gave a warning saying, you know, you're about to make this public. Are you sure? Okay. But it is kind of funny how they give you an option like, do you want to make this private or do you want to make this public for testing? Doesn't matter what you choose. We're going to make it private. Keep in mind that that Google bought Firebase, so they're probably still making some changes as they kind of integrate it into their system. But this was several years ago they bought Firebase, so don't let Google too much off the hook. All right, so this makes sense? Now, I'm going to click back on Firebase here. The project I created for my app that my app is married to is CUW Spring 2019. It just happens to be called that because I was like, when Firebase wasn't working, I was deleting projects and adding new ones until I finally determined that Firebase was actually down the afternoon I was trying to do this. So this just happens to be the name of the project I created that I have my other app hooked to, the one that we've been working with. So if I click on this guy, I go to database. We already have a database created. Here's my real-time database. If If I go to rules in here, notice they're both true. So I have it set up the same way you guys would have yours set up. All right, I'm just talking to this other project. Everybody's cool with how you connect your app to Firebase? Pretty easy with Android Studio. A couple little stupid caveats that they probably should fix, but whatever. Trust me, if you didn't have that, let me actually show you something here, because there's some magic that happened behind the scenes. I'm just going to go over here to my app. I'm going to right click and I'm going to say, I'm going to say reveal in Finder. I'm just going to go to the actual file system on my computer where this guy lives. Okay. And is it inside of app? Yeah. I don't know if you can see this here, but there's this file called Google Services JSON. That is something that was created from Firebase and was downloaded to my computer. And if I open that file up, it opened it here in Atom. It's just a text file. Okay, notice this is where it's connecting to my application. So here's my project number. Here's the Firebase URL for my project. Here's my project ID. Here's my storage bucket. A whole bunch of crap that uniquely makes my app here talk to a specific project on Firebase. And that all got created for me automatically. Had I done this in a different language, I would have had to use Firebase to generate this information and manually have put it into my application. Does that make sense? Would have been less friendly. Not that big of a deal, just less friendly. Okay? Our focus in here is not on the inner workings of Firebase or anything like that. Our focus in here is we have an application that's going to use a database. All right, so from this point forward, once your app is connected to Firebase, we're not going to worry too much about that magic. You make your development tool, talk to the database. Good. If you're using a different database, you'd make it talk to it differently, but once you get it connected, now they just talk. Make sense? Okay. So, I'm going to go ahead and close this project. And here is my original project here, the patient record example project that I already have hooked up to that other Firebase project I showed you. All right, so now let's go through a few things here. So one of the things that we want to be able to store in our database is patient records, or for you basketball players, right? We want to be able to store those things. So what I'm going to do here, I'm going to go ahead and open up my patient record, and you're going to see that there's some modifications that have been made here. Okay, so one of the things is we have this exclude thing from Firebase. We also have something called serializable. Okay, now serializable is actually something built into Java. It says that this particular class can be turned into JSON. That's what serializable actually means. Means this class can be converted to JSON. Okay? Now, this guy right here, the serializable guy, we have something called an interface in object-oriented programming. So an interface is kind of like a class, but we extend classes while we implement interfaces. So what's the difference? When we extend a class, we get all of the, I'll just put it in quote, things from the parent class. and we can override the ones we want to work differently. So this is similar to what we did with our array adapter last class. We extended the base array adapter and made it our own special version of array adapter, right? So if I show you in code here, we had this dude called patient record array adapter, and notice this guy extends array adapter. So our patient record array adapter is a array adapter. He's a plain Jane array adapter, but then we differentiated him by writing our own version of getView. Clear on how that works? Okay. This has nothing to do with array adapters. This has nothing to do with even Java. Inheritance is something that all object-oriented languages have. When we extend a parent or we inherit from another parent, from another class, we get all the stuff from that class, and then we can go and differentiate ourselves. All right? So, when we implement an interface, we are agreeing to follow a set of standards that will be automatically policed by the code. All right, so let me show you what this means. Serializable is actually a bad example of this because it's kind of a special keyword. It's a special interface that doesn't actually make you write anything. It instead lets Java know that you want this guy to be able to be converted into JSON. So I'm going to show you the serializable interface, but then I'm going to actually show you an interface called runnable that's used for multi-threading that we'll look at some point. But that guy has a single method that we have to implement. And if you don't implement that method, it'll scream at you. It'll say, you said you're implementing runnable, yet you never wrote the public void run method. While we agreed to follow that set of standards. We agreed to write that method. All right, so let me show you in here. Serializable. So here's the documentation for serializable. All right, so built into it, we have this thing called write object and read object, but they're actually provided for us. They know how to handle Java classes. It just says that we had to follow the rules about making our fields all public, and I'll show you that here probably next time we actually look at this in depth. Okay, but let me show you runnable as an alternative to this, just so you can really see how interfaces work. So I'll go into runnable. All right, notice it's an interface called runnable. This shows us sub-interfaces that operate off of it, but most important for us is there is a method summary for runnable. We have a method called public void run. So if we create a class that implements runnable, we have to write our own version of public void run. That's a requirement. If we claim to implement runnable and then we don't write public void run, it'll scream at you saying, you have not written public void run. You've agreed to implement this interface, so you've agreed to write all the stuff this interface demands, yet you didn't do it. Does that make sense? So it's kind of a self-policing type thing. And we'll see examples of that. So right now at the high level, just trust me that we needed to make our object serializable so that when Firebase goes to store it, it can turn it into JSON. When we retrieve it from Firebase, we can turn it back into an object. Make sense? Okay, so for Thursday, Make sure all of you are able to get your projects successfully connected to Firebase. So create a database, create a real-time database up there, set the permissions to true, and I'll ask you to submit some screenshot from part of some aspect of that process. Sound good? All right, and then on Thursday we'll come back and I'll show you how to read and write things specifically to the database so we can take our stuff and put it online.
Do you want us to add all the code as well?
No, you don't have to add the code yet, just connect it, because I'll be explaining the code next time.